The views discussed in this conversation are the views of individuals and not of Arrington Capital. This podcast is provided solely for informational purposes and is not financial, legal, tax, or investment advice. The participants of this podcast are not recommending any particular security, protocol, token, financial instrument, or other tradable asset or any investment strategy. It is not offering to sell or soliciting to buy any security or asset.
Hi everyone, welcome back to the Pirate Pod from Arrington Capital. We have NovaNet with us here today, and we're going to get into what's probably going to evolve into a pretty technical conversation. We met the team here about a year ago, almost to the day, and invested in NovaNet. NovaNet's a decentralized peer-to-peer network that enables fast and memory-efficient zero-knowledge proofs for a wide range of use cases. It's a fully decentralized proving network, making zero-knowledge proofs portable and accessible across a number of different environments. We're going to get into all of that. I'm super excited for this. My foray into crypto was back in 2017 or 18, and I was first working for Silvio Macaulay, who invented zero-knowledge proofs in 1985. So I'm excited for sort of this deeper dive and how Wyatt and Houman have expanded upon the cornerstone of modern cryptography. So before we dive into all of NovaNet is doing, let's do quick intros. So Wyatt and Houman, can you share your journey from your previous work and what led you into starting NovaNet and your venture into blockchain? Wyatt, can you start us off?
Oh, I am actually a serial technical founder. I've founded many companies that worked for private equity before that, and actually was a venture capital way before that as well. My last company was actually a digital office space, and I was based in Japan at the time, and it was this digital office space. Really, why would you need that in 2019? But then the pandemic happened, and it just happened so that most of the major universities in Japan started to use it, and the company ended up being acquired by a Swedish gamification company. I think they actually pivoted to a little bit later to make it Web3-esque, to give like rewards for going to this digital office space. But I came back to Web3 after a long hiatus. I've known about Web3 for basically ever since it existed. My brother was using it when I was very, very young to do kind of illicit things with Silk Road and whatnot. So I've known about it for quite a long time. It wasn't the best impression, but coming back as a technical person in 2021, there's a learning curve for me to get up to speed. And really what we had first was kind of a no-code type mentality to Web3. Like, how can we make this tooling easier for lawyers and other people who are not technical? And that's kind of the start of our company now. We actually had a few lawyers ask for a ZKP, which is a very specific technology. It was very hard to use any of the tooling out there, so we decided to create some of our own.
Houman, you want to give us a little bit of your background and how you ended up here?
Thanks for having us. My background comes from the law of all things. Prior to NovaNet, I was basically a full-time law professor, and my journey in crypto began 2014 or something when Jerry Brito, a former colleague of mine and the founder of the Coin Center, I think he stepped back now, but he wanted to write an academic legal article on the regulatory implications of these new things called cryptocurrencies, Bitcoin, and this is even before I think Ethereum had its ICO. And so I came at this whole space from the legal regulatory angle. I testified before the CFTC on Bitcoin derivatives and commodities back in 2014. So that was, I think a fairly early time in the space. And my journey as an entrepreneur, though, came from just having that itch, wanting to really be a builder and a starter and to really create something. Seeing lots of people take their ideas and execute on them, people telling me they're using my ideas in their companies. So I just had an opportunity to start a smart legal contract startup back in 2016, I think it was. And then at the time, certainly I had heard of zero-knowledge proofs through Zcash as a privacy preserving tool and alternative to public transparency blockchains, everything being on-chain. At the same time, my interest in no-code applications was developing, really empowering, citizen developers and all that. And that's how I came across paths with Wyatt, we were both very interested in Web3 and enabling people to build on Web3 without necessarily having to code everything from end to end. That led back to the kind of renaissance and the resurgence of ZKP as a really cool use case, not just for privacy, certainly also, of course, for scaling. We're really trying to bring ZKP back to its roots of privacy preserving verifiable compute, as well as like kind of where it maybe started, just like at the intersection of Web 2 also, because we're seeing lots of companies from TikTok to Google having interest in ZKPs as well.
All right, so let's get into it a little bit. But first of all, zero knowledge proofs, a way for one person or a prover to convince another human or a verifier that the known fact, secret statement is true without actually revealing that secret statement. But you can prove that it's true. And so zero knowledge proofs have been around, like I said before. I think Silvio authored that with Shafi Goldwasser back in 1985. What is the take from the two of you? Wyatt, let's start with you. What's your take on where we've been able to leverage zero knowledge proofs since 1985 and in the past decade, specifically in crypto, and why is that not enough? And then we're going to work on like how NovaNet builds upon that. But like, what's your take on where they've been and what their potential has been and where they're going?
They've been very much focused on scaling constrained blockchains. So for scaling, basically Ethereum has been the main goal. Most of the early proving schemes, they're aimed at making verifiers cheap enough to run on blockchain. So something like Groth 16 that is small enough to even run on Ethereum. There's been many like scaling startups that are focused basically on very big ZKPs that run very quickly and or enable validated proofs to get done with ZKP. We actually took the other perspective, which is, hey, this stuff is really fast now. Like maybe we should make it more memory efficient. Maybe it should work on many people's devices if we want true decentralization. Because with these large scale ZK VMs, they are very centralizing. You need a special machine to run it. You have to have a special setup and run very special code and even special hardware. So this is kind of the antithesis to what we want to do, which is make ZKPs basically run on everyone's devices for various types of use cases. And with this, we use something called a folding scheme that's extremely memory efficient. You can actually pick the step size for your machine. So if you do have a big machine, you can obviously run very quickly. But if you have a smaller, more constrained device, you can run smaller. And with this, we do get local verifiable compute because the stuff is actually running locally. And we also do get privacy as well. So a lot of the ZK VMs you see out there in the space right now actually don't support privacy whatsoever. So with ZKP that actually run on your device, we can actually support that use case as well. So yeah, you could have privacy with constrained proofs like Groth 16. So Tornado Cash was a good example where you can actually run a privacy protocol running on your device. But it was very limited to these kind of like toy type things that were involved with privacy. There wasn't like a general purpose ZK VM for privacy. So what you had was a bunch of startups that actually focused on basically scaling Ethereum. Like how can we make ZKPs big and fast and be able to do these validated proofs? And this is in contrast with like Optimism, which is a different type of L2 as well. So there's this whole narrative behind L2s. And I think for the last 2 to 3 years, like ZKPs have been sucked into that narrative. And the Ethereum Foundation is actually very focused on something called ETH proofs now, which is all about getting these validated proofs to be real time. So there's a space that is very focused on this that takes special machines. But when you do that, you do get more centralizing factors, right? Like anyone who has a big enough machine, they might have to spend special money and hire these special people to get these things running. And then it's basically a few companies that are able to even to do that. But with folding scheme, what you can actually do is you can have very, I would say, flexible ZKP. They can run for various different use cases that Houman, I'm sure, will be able to go over. And these use cases, I feel, are personally more powerful. They're not just about scaling a blockchain. They're about local verifiable compute. So think about like AI or proof of location, stuff like this. But I'll let Houman go over a few of the use cases.
Can you talk a little bit about the peer-to-peer decentralized prover network? Like, how is that going to very broadly redefine how people interact or transact?
Yeah, so there's 2 different use cases for that. There's top-down proving, which is taking a big proof and breaking it apart. And we can all collaborate together. Like we could be on this meeting or this call right now, and we could all be working on a proof in the background. So you can think of things like AI that are computationally expensive, and we might want to collaborate to get done in a more quick way. So a good example is like, hey, I want a ZKP to trigger a smart contract that releases funds, and it might be too big to run on my personal computer. I don't care about privacy. I just want to get it done quick. So I can get together with my friends and we can all do it together. The other is a bottom-up proving, which is like privacy proofs that are smaller that we all run. It could be something like a ZK game or a ZK proof of location. You don't want to expose your location to everyone, but you do want to prove that you're in the state. I'm in Florida, but I don't want to, or I'm in XYZ, but I don't want to give you like my IP address or my geolocation. So that type of use case, what you have is a bunch of small devices making proofs. And if you want to post it to a blockchain, it's expensive. Like one proof, it might be $10 a piece. If you have 1,000 users, it's extremely expensive. So what the network does there is actually aggregates these and makes it one succinct thing for you to post on chain. So with ZK games, you might have 10,000 gamers and they post one very cheap thing on chain rather than each individually posting.
What are the prover networks that are out there today? Like how are and Houman, you probably have a really unique with your background, like a unique approach to your perspective on like sort of how privacy concerns are being alleviated and the gaps there.
Most of the proven networks are very focused on scaling Ethereum, and with that, they've made design decisions that I don't think are the best for various use cases. So one example is like proof racing, where you have these proven networks that are out there. I think the very earliest versions like nil and maybe even SP1, so I don't remember exactly. But a lot of these proven networks first did proof racing, which is like, hey, the biggest and fastest machine gets the proof, and they run through it, and if they win, they get the prize. And the horrible thing about that is if you like give your proof to someone to run and then the machine dies midway or loses connection, you have to start from the beginning again. You have to like wait all over from the very beginning for the proving start back up. So that like very naive approach, I think, was very focused on once again like speed. Biggest, fastest machine wins the race, they get the money. And that has nothing to do with collaboration, like in our type of use case. Like if we want to get speed and work together, it obviously won't work in that type of prover model whatsoever because we'd all be competing in that perspective. But if the three of us were actually friends and we wanted to work together to get the proof done, our prover network is actually more usable for that type of use case.
You mentioned DPIN, right? Exact location without giving your location. I think that's a good example. Let's run with that one. How are those applications working right now when it comes to zero knowledge proofs?
They're actually basically ignored for most of them. Like they were looking for ZKVM solutions.
What do you mean they're ignored?
Yeah, so they went to various ZKVMs that exist out there in the space already, and they tried them out. So this is like Risk Zero, SP1, all these other big ZKPs that were made for scaling Ethereum. They tried them on these smaller devices, and like, holy shit, this is not going to work on any of these devices. Like, this is completely impossible. So they just assumed, like, hey, ZKPs won't work for our use case. But when they stumble upon folding scheme and our use case, they say, oh, wait, ZKPs actually can work, like, on device and on these edge smaller devices. And it's not that memory efficient. Like, it's not required that you have 100 gigabytes just to run these things. You can actually run it in under 500 megabytes, which just opens the door for the deep-in type use cases.
Houman, what are the legal frameworks that come into play when you're looking at some of this stuff?
Yeah, as you mentioned, privacy is a big legal issue, and one thing you find out pretty quickly in today's ZKP space is that despite the phrase zero knowledge, most of the major ZKP systems are not actually privacy preserving or zero knowledge containing, because they are centralized in the sense that you send your data to a centralized prover network or a third-party prover network that uses that otherwise private data to generate the proof for scaling purposes. And that's great for scaling purposes, but not great for privacy purposes. And so that's why the memory efficiency work that we've done at NovaNet is so important to bring ZK back to its privacy roots and to comply with regulatory requirements in the simple sense that, hey, if I don't send user data anywhere, or user data never leaves their own machine, privacy laws are not implicated. They're not really even triggered in the first place. So that's very helpful.
So with that, you don't think any legal issues will have to be addressed or concerns more broadly worked on from a regulatory or a legal perspective, given the advancements of something like NovaNet? They're more like alleviated because they're non-issues?
They, in the sense, they become non-issues, but that would have to be kind of confirmed and explained and understood. But zero knowledge proofs, at least some regulators, and maybe in this administration increasingly so, would accept them essentially as a form of compliance. And we're working with looking at technologies that enable us, like Circle, to prove compliance with a fairly straightforward regulatory compliance API. Prove compliance with that without revealing a lot of details. And that could be a good connection between ZKPs, stablecoins, and a kind of a bridge between Web 2 and Web 3, because you can show compliance with but then go take that compliance proof and use it on a DeFi platform or something else that would presumably be able to accept it and use that without having to dox the user.
What is parallel proving?
Yeah, so this is called continuations, which is parallel proving in a sense that you break up a big problem among many machines and you run them together and then kind of fold them back into one final proof. And this is potentially the quickest way to have proving for large prover tasks. It was originally pioneered with Risk Zero with the continuations. We're using something called Hypernova. That's like the most efficient way of doing this in literature anyway. And with this, we can have many machines work on one problem together in a collaborative way. and have a proof.
And that's where you have NovaNet, where you have more and more people that are able to participate. So you have this more decentralized, efficient memory storage. Okay. The other thing I was thinking is when we have zero knowledge proofs in a way that you're kind of outlining with NovaNet, what does that mean? What does the inclusivity of people participating, zero knowledge proofs being decentralized, having these parallel proving networks where many people can participate in that? It's more inclusive. What does that mean for, take DPIN, take gaming, take AI, take any of the examples you're sort of seeing at the core of what you're doing? What does that mean broadly?
I think it's more like a real if we all were doctors, we obviously wouldn't have a really good economy, but since we have various different occupations, we have specializations. So you can imagine various different users that might have low powered machines that can contribute with their own small proofs, but you might have specialized machines that are really good doing like ZK AI or ZK FHE or these other more advanced topics. And they can all kind of collaborate together to attack proofs that might be infeasible for one person. So we get the specialization factor, which I think is really interesting because you also get like scientists come into your network then. People who used to make code for free for like research projects join your project then to try to get like the best state-of-the-art ZK AI, ZK ML, or a ZK specialization and potentially earn from doing that. Before they would make some open source code, maybe a paper, but now they can actually do that and also potentially earn money by having a faster prover. And this is true with hardware as well. Like there's a bunch of companies out there doing ZK specific hardware, and these are specialized provers, and they can potentially join the network. But one other thing is the fact that you can just have these gaming computers that people already have. They could be in a meeting doing something else and potentially earning money or coins and tokens in the background for joining the prover network. So I think in terms of centralization, a lot of the prover networks have been very centralized with special machines. But with this type of use case, we can break up the proof and match it to the specs of the machines that might be proving.
And you're talking gaming computers, so you're talking pretty high level. You're not talking about an average iPhone that someone's sitting around.
You can do it with like your browser that works in under 2 gigabytes. Obviously, the types of proofs you'll be doing are smaller than the powerful machines, so the amount of tokens you might be a little bit less. But from there, most computers today have GPUs, so you'll be able to join if you have like a GPU more generally. So I'm pretty optimistic that it's going to be the most widely used, and there's been a few tests actually by other teams as well that tried this through GPUs. I think Nexus tried one as well, where they had like 10,000 people join and run a proof through browsers. And I think with this type of folding technology for privacy proofs, it's essential that it runs on device and in smaller spaces. And they won't have to do big proving then, but it's basically just be running the little things that they need to run their device. And it might be a specialized machine that's doing the aggregating.
I'm going to ask a question that might be a little uneducated here, but what is proof racing, and does it have anything to do with how many people are solving these proofs within ZKP networks? And what are the sort of inefficiencies or efficiencies and any privacy concerns with proof racing?
Yeah, so the way proof networks have worked in the past is basically you would have people compete to say, hey, I will give you the best price and the fastest speed for the proof. And when you reward that person, you have to wait for them to finish to prove that they can do it as fast as they can. And normally this is like the biggest machine, like whoever has like a very big AWS server running somewhere, they'll normally win this. It has a few different issues. One is the liveliness factor is really bad. So you wait for this person to get done, and if they fail or if they say, no, I don't want to do this anymore, you have to restart from scratch, which is pretty bad. And with our type of system, which is using folding schemes, you actually stop, go, stop, go. So someone can stop midway and someone else can pick it up. So we were talking about smaller machines a little bit earlier. So you might have a small 2 gigabyte machine, you ran it through a few different steps, but you guys pass it on to someone else and they can continue midway.
Do I get nothing for starting it on my smaller GPU machine?
We're using pretty cool economics to make this fair for everyone. But there is a base, like if you're using 2 gigabytes, you will get something in return just by default, which is kind of cool from a systems perspective. But if you do end up passing it on, like you stop midway, like your network cuts out whatnot, then someone else can just pick it up, which I think is really cool with folding scheme and IVC in general, which is incremental verifiable computation, which might be too deep in the weeds. But that's one thing. Like, you don't want to do proof racing if you can collaborate with people and potentially pass off proofs.
Okay, so it's collaborative, not racing to beat people. All right, fine.
Yeah.
Is there any game theory involved in how it gets done?
Yeah, lots of game theory involved. We use something called Shapley values, which is also using AI to kind of fairly reward people. And when I was talking about the base value earlier, like if we want to go really technical, Shapley values are very hard to calculate. But we have a method that makes it fair for the lower tier computers to get a fair portion, and then pass up higher portions of stronger machines. Like I mentioned aggregation earlier. these might be bigger machines. Like these are ones that are controlled by partners or traditional validators that might work in a blockchain, and these do high-powered aggregation in the system. And they obviously need to compete sometimes as well. So there's also competition in our network as well, but at the lowest level, there's not. There's collaboration.
And it's also a big deal that NovaNet has this modular design, which I don't think is necessarily tied to all of these different participants proving it. Can you talk a little bit about that and what it means for participants in the network, as well as also developers who are building things on top of a proven network?
Yeah, one thing I think that's important to kind of highlight is the fact that we don't lock anyone into a specific blockchain. We have a EVM compatible verifier that works in 750,000 gas, but you can potentially use it like on Solana or any other constrained blockchain. So we don't really get people stuck. Like we're super modular in the sense that it's peer-to-peer completely. You actually spin up your own orchestrator node and your own general purpose node if you wanted to. And you also post onto the L1 of your choice. Obviously, since we're using mathematical proofs, there is a rewarding mechanism that's based on the maths as well. But that's a huge part of the modular framework, is that we don't really want to confine people to one specific blockchain.
Yeah, and what does that look like? Are you picking? Go ahead, Houman.
But yeah, I think that modularity in a sense runs throughout the technology, because a ZKP, ZK virtual machine, ZK WASM in particular, is a very general purpose technology that can run in a lot of places and prove basically almost anything. And that's different than a lot of ZK appended technologies or other stacks you may hear today. And the great thing is for developers looking for proofs, looking for verification, is they can fit it into their own technology and integrate it in various ways. They can run it locally on their devices. They can run it in their browsers. They can do something more centralized on edge devices, basically on any chain they can verify, or even verify off-chain if they like to. And it makes it really good to develop with, including a wide variety of kind of even Web 2 based tools to test things out for many different use cases. So I think modularity is really good to allow developers to use the core engine as well as the network in a very kind of lightweight way, and to use it for whatever their use case is.
We're talking a lot about cross-chain. What does it mean to be cross-chain with prover networks? And I think you've mentioned this verifier lock-in across different blockchains. What does that mean, and why is the flexibility of cross-chain and different blockchains important here?
Yeah, there's a lot of teams that work on Starkish type systems, which are a bigger type of ZKP scheme from a few years in the past, and these are more.
What do you mean? What do you mean by bigger?
They take more memory, so they normally require like 80 gigabytes or more to run, and also the proof sizes are much larger. So you have this bigger data structure at the end as well that you need to pay for. And if you're doing an L2, it makes sense because you're like amortizing thousands of users and then posting on chain. But if you're going to try to use that for like general purpose use cases, you end up paying a lot for nothing unless you're amortizing across a bunch of different, once again, like L2. Like this is why you have to wait for a lot of the more traditional L2s to kind of finalize. It's because you're waiting basically to amortize these costs to get posted at a fair deal onto the L1. So with that, you do get lock-in, right? You have to wait for whoever is doing this validation to finally post, and you can't really like leave a roll-up without doing that. But the ZKPs themselves, they don't need to do that, right? There's a mathematical object. If you have a smaller one, anyone can, with the verifier code on the browser or wherever their device might be, can verify directly. So there's no like fundamental reason why it should have been that way. It's just the fact that it was just the way it started. And now a lot of people actually end up wrapping these bigger proofs into something smaller called Graph 16. The issue there, though, is it has a trusted setup, which means like you trusted someone to do this fancy ceremony and make sure they didn't cheat, which is obviously like if you want full decentralization, you might not want to trust someone to do that. And then once again, like those type of Graph 16 setups might be focused just on Ethereum. So if you try to use this EVM, you might just be stuck using basically Ethereum-based EVMs. And a lot of the deep in space is not even on Ethereum right now, like it's on Solana or these other chains. So we really don't want like to lock any of these people in. And also Web 2, like Houman mentioned earlier, like Web 2 obviously doesn't want to be on, in some cases, any blockchain. They just want to verify things in their own servers somewhere. So without having them to do or post specifically on 1L1, we allow a lot more freedom.
You all have been building this for a year or so now. How far down the path are you of having actual applications, whether it's people that are migrating over from stuff that didn't work or net new applications? How far down the path are you of use cases that are hands-on using and really using NovaNet?
So we actually have a closed beta right now. It's already running up on the base ecosystem with the first version. And this, like, if any partners want to try it out, they can. We even have a web browser version where you can basically go in and throw it a large group and have it run distributed top down. So with this, like, we already have people using it from the top down perspective. From the bottom up perspective of the privacy aggregation proofs, we're actually doing ZK proof parties, which is our own kind of dog fooding. And we're going to demonstrate basically the power of it that way. Houman, you might want to take it.
Yeah, I mean, it's very the network's ready in private testnet, and the core technology, the virtual machine, is up, and so I'm finding lots of different use cases online to connect it with and to run it. We've done a demo with Circle. We've done basically running proving compute on a sensor device. Building demos for all of these things. We're connecting stuff to different type of AI agent, crypto agent frameworks as well. And as a kind of precursor to the full-blown ZKML release that's coming out later this year. But there's a lot of things that can be verified about agents besides their inference and stuff. And so that's important. And so because you can basically download it and run it on your laptop, you can connect it to any API, open source software, and things like that. So there's just really no end to the ability of the NovaNet's ZK engine, we call it, to prove anything out there in the world. So it's exciting. And using all these vibe coding tools, basically anybody can get out there, text a couple prompts, and it'll tell you, it'll read the open source repo, tell you how to download it, or plop it in your browser, and go from there.
What do you think the most prominent real world use cases are using NovaNet 12 months from now?
I think it's super cliche. I'll let Houman do the deepen one, but one of my favorite ones more recently is the AI type use case. There's a proving scheme actually backed by A16Z called Jolt, and it's really big prover once again, like it's made for speed. But via using folding scheme in our technology, we can potentially make Jolt smaller. And with this, like if you have small local models running like on your device, you can potentially prove things about those models. So these aren't like LLM inference. These are actually smaller type of models, maybe to make predictions and things like that. So if we had the state of the art in terms of speed and we're able to make it small enough to work on your device, you can have this chain of AI agents, which is kind of like been trending, kind of a cliche, but we might actually end up with the state of the art for being able to prove these with these our specific type of folding scheme. And then with that, you can imagine like workflows in Web3 and also in Web2, where your AI agents are using privacy, interacting with other agents outside of your computer to do novel and really cool things.
And I know you've spent some time with the DPIN one. What do you see next year? But then it's also like, where do you see NovaNet impacting 5 years down the road? Is it finance? Is it healthcare? Is it legal representation? I don't know. What are those areas that are further down the line?
I think all of those areas you mentioned can be improved with ZKP as I think Web3 and Web2 converge. In the next 5 years, a lot of people will be looking for solutions that just work. And ZKP is not really necessarily a Web3 technology. So people want cryptography, people want verifiability and privacy and all that stuff. And zero knowledge proofs can provide that irrespective of whether it's on or off chain. But the beauty about the technology is that it is very applicable to blockchain use cases, both from scaling and just public verifiability. Because, hey, if you want to say anyone can verify this proof is true, and what technology exists for anyone to go use? Well, it's these open networks called blockchains that can be the verification layer or component of otherwise private proofs. And that's why there's a really good fit between zero knowledge proofs that are done privately and off-chain and zero knowledge proof verification that's done publicly and on-chain, because you get the public verification benefit while still maintaining the private local benefit of privacy as well. So that's very
Yeah, and you're right. You can see how that'll impact it, like ownership and what you own and what you want people to see versus not, what payments or taxes you've paid versus not, right? Like there's a whole bunch of things that you want to maintain that privacy around. I assume that most average end users of any applications that have NovaNet implemented in some part of the stack aren't going to care, right? They're not going to care about this tech. Things will just work. That's not a thing. I don't think we'll ever get to a point where people are like, is the zero knowledge proof decentralized? Now, wishful thinking, but would you agree with that statement?
I think the same with Web3 more generally. Like, do people really care if they're running on the blockchain or not? And in some cases, they do. But if you actually had real-time ZKP, like you were able to run a computer and run at the same time, it actually might become a new form, like the new edge of blockchain itself. Like, you might not need a traditional blockchain if we all just verify these tiny proofs by passing them to one another. But in the long run, 5 to 10 year range, it might actually completely change the way we think about blockchains and how they interact. Rather than doing just this old traditional consensus, we might just have ZKP with a consensus layer. We'd all be passing these proofs like from our machines directly, which I think would be very cool.
That's a spicy take, Wyatt. That's a good segue into, can you talk a little bit about incentives, participation, contribution, how people are incentivized to participate in the prover network and how that's working right now and in the future?
So from the bottom up type proving, what happens is there is a customer, it might be like a gaming company or a deep in company that wants to aggregate 10,000 proofs. And when you're doing this proving and this aggregation, you're getting a part of that reward. So for a gaming company, it might be, hey, I want to do 10,000 proofs for $100. And we break up those rewards using, like I mentioned earlier, something called Shapley values among the participants that run through it. The base of the cost is also what it takes to post on the blockchain of their choice. So there's this like kind of fixed cost of how you get on chain. That's how that would work. And for the bottom up or the top down type proving, is once again, like what's the customer willing to pay. And you can have basically different orchestrators that are saying different prices for the amount of opcodes, and you can choose among them. If you're Microsoft or another one of these companies, you might actually just choose your own orchestrator and pay that each time, or you might choose a very specialized orchestrator. You have a lot of freedom in choosing which orchestrator as the end user. Like, we don't want to say, this is the one you always have to choose, or we're going to select from a random pool. It's basically off the freedom of what you can see in the marketplace.
Do you think that average crypto curious people will ever be incentivized to go participate in that, or it's too much?
I think it's going to be running in the background. So you might be playing a game anyway, and you might just want to earn some extra points or in-game items by running this in the background while you're playing your game. Or like I might just be searching the web, doing something random, and I have this plugin in that is potentially giving me a few coins or tokens while I'm searching the web and doing other things. And I think there's already kind of a basis of this, with like Geekgrass and these other type of schemes where basically you have a user have a Chrome or plugin extension and you're using their compute as an aside.
Are there any particular developer ecosystems that you're more focused on right now over others?
Yeah, we like the base ecosystem a lot because it's having a lot of growth and they're also very privacy focused. I think both Ethereum and most of the L2s now are focusing more and more on privacy as something that's more fundamental. And obviously with that, you need technologies like ours to make things truly private. So that's where we're starting. There's a few others like AVAX and the ICP ecosystem that we have roots with. They actually participated in a few of our rounds in the past. And those also have interesting use cases in terms of privacy as well.
So what comes next? You've been building this for a while. You've got the private beta testnet. What are the next major milestones for NovaNet?
We're actually doing ZKP.fun, which is proof parties, and we're demonstrating basically the state of the art in our categories for a bunch of different things. So if people go to ZKP.fun, they'll see new challenges that appear that you can actually just press a button and run in your browser. Right now, it just gives you like these artificial points that don't mean anything. There's already been hundreds of users who have tried things out. And it's very focused on people who don't know anything about ZKP. It's like, hey, press this button and see, like, make a proof.
That's awesome. That's great.
Yeah. So we're going to do that, and we'll show like state of the art, like set membership. One for the basic is more like, hey, I have a base name, but I don't want to dox which one it is. Like, I own a base name without giving you like all my private information that might be associated with it. So these type of set memberships, like I own this NFT, but I don't want to show you which Ethereum address is exactly associated with it. So we're going to be doing a few of these things that are kind of more demos to show people what the technology can do. And then from there, we'll make it more into production type of thing. Like actually a ZK base name would be really cool to have. So.
Houman, what are you the most excited about for what comes next on NovaNet?
Yeah, really everything Wyatt mentioned, as well as more widespread adoption of our technology and the network by agents and by DPINs. I think that's going to keep us busy for quite a while, as well as just being considered a fundamental privacy primitive for either various chains or maybe gaming ecosystems. as well. So I'm excited because there's such a wide variety of applications again, and we're demoing the technology in different ways too, so people can see what's actually possible. I mean, that's kind of the point of proof parties. So you can kind of make it as tangible as possible, running in your browser with various challenges to earn rewards, as well as just seeing it prove really fast and not reveal anything else besides the fact that it proved what's true. So that's super exciting.
Yeah. Is there a token associated with NovaNet?
We're calling it NVX. It's on base right now, but there's no TG yet, obviously. But really, like our first customers are CTOs and other technical founders. We've been focused on that, but now we're trying to make it more like students, researchers, to make it a broader and broader category. So I say anyone who's looking into the space now, they're super early into getting into like memory efficient ZK.
Awesome. This is fantastic. Anything else you want to share today that we haven't covered so far?
Yeah, I just invite anyone watching this to come try out the technology. It's very accessible, very buildable. You can build with it in many ways. And please come check it out.
All right. Well, I will drop links in the show notes to follow you on Twitter and all your dev docs and website. In the meantime, Wyatt, Houman, thank you so much for joining us on the Pirate Pod today.
Thanks for having us.